Good. I need to.
Okay, Angel, we are starting 5-6. Here's the homework. It's very short because we've already been doing this stuff, and I don't want to like do too much because we've already been doing this stuff. So here is some more. This is called the fundamental theorem of calculus, and the fundamental theorem of calculus says this: if you are finding an integral or evaluating an integral, meaning finding the antiderivative. This is saying, if you're trying to find the area underneath of the curve of f of x from a to b, you put b on the top, you put a on the bottom, and then you plug in b, and you subtract what you get when you plug in a. Now, I know Reese has asked me this before, and I explained it to her, but I don't know if everybody else understands this. But when you are finding the antiderivative, technically there is a plus c on the end, right? Yeah. Like, there's plus c, okay? Yeah. But here's the deal. If you plug in b, and you still have your plus c, and you subtract what you get when you plug in a, your c values, this is c minus c, and your c values cancel. So that's why we get to not have to worry about c's when we're doing a definite integral, right? Definite means it has numbers to plug in, yeah? Okay, so that's why we just have to do f of b minus f of a. This is the fundamental theorem of calculus, which we've already been doing, I feel like, this whole time, okay? Now, these, I think in the next section we're also doing this, but we're doing it alongside the substitution stuff. So we'll be doing this again, but we'll be doing substitution, like the u and du and that stuff, along with substituting numbers. And there's kind of a little trick there of how you do that. But we're going to continue this on again for the next section as well, and that will be another like extension of the fundamental theorem of calculus, but with u substitution. Okay, example 1. Here you go. Evaluating from 1 to 2, we are finding the area underneath of the curve of x. So just FYI, so you know what you're doing here, like you know what you're evaluating.
1/2 x squared.
X is the graph y equals x is a linear function that looks like this, right? And you are finding the area from 1 to 2. So you are finding like this little area right here. That's what you're finding. What?
So, on the last notes we did, we said like you have to flip it so it's across the y equals x.
Yeah.
And like so we flipped the code, we flipped it, but it was up and down and not like on the line.
Uh-huh.
Is it supposed to be going from this way to this way? So
Yes.
that, like,
yes.
Like the line intersects it, or are we supposed to go along the line?
It is technically along the line y equals x. So like the sign, don't listen to this, whoever is watching this. Here's your graph of sine, right? If I reflect him across this line, he'll literally go this way.
Okay.
It's really strong, so I need to.
Because every point, so...
I'm gonna draw.
So, no, just wait. Like this. This is what sine looks like, right? Mm-hmm. Okay. This is the graph. This is like pi over 2, comma 1, right? So instead, you'll go 1, comma pi over 2. So he will look like this instead. And he'll be reflected across this dotted line. So the pi's will be along the y-axis instead of on the x-axis. Okay, moving on. Okay, so 1/2 x squared. Here's our notation. We've found the antiderivative. I have not yet plugged my numbers in. So do you remember what we do to like note that we found the antiderivative, but we've not yet plugged the numbers in? I put a line at the back that says 2, 1 or 2, 1, and then now I plug my stuff in. Got it?
Got it.
So I'm gonna plug in 2. So 1/2 times 2 squared minus 1/2 times 1 squared. And this guy you said was how much? 2? 2 squared is 4. 4 times 1/2 is 2 minus 1/2. So 1 and 1/2 is the area. Okay, I can see where. Check it out on my graph. On my graph.
We do a triangle and a square.
1.5. Do you see 1.5 squares there?
Sure.
1.5 is the area. Okay. I did a good. I did a decent job. Hey, there you go.
Stupid little line trick.
Oh, okay. Josie's violent today.
Okay, example 1.
I'm just tired.
We had a long day yesterday.
You know what? My mouth is still like in excruciating pain. I told myself I wasn't gonna talk today because of how much it hurts. Feeling a little better, clearly.
Okay. All right, example 2. We are finding the area under the graph of 9 minus x squared,
9x. Wait,
which is a parabola facing down up at 9, yeah?
I need the graph.
Okay. I just drew the graph for funsies. You don't have to draw the graph if you don't want to.
Josie
We're up
has
at
to
9,
draw it.
and then we're going like this.
Don't understand.
This is what 9 minus x squared looks like. Beautiful?
Beautiful.
Beautiful. He's up at 9, right? 9 is the y-intercept, okay? We are finding the area from 0 to 3. This guy right here.
Yo.
Okay. And then I'll show you a little trick.
9x minus 1/3 x squared.
9x minus 1/3 x cubed is the antiderivative going from 0 to 3.
Yep.
Now, the really nice thing about 0 being the bottom number is because
We don't have to subtract it.
minus, if you plug in 0, you're going to get 0. If I plug in 3, I get 27 minus 1/3 times 27, right?
So it'd be 9.
So it'd be 9.
27,
27 minus 9 is 18. 18. Okay, now, little tidbit. I think this is going to appear on our notes at some point, but, ready? What if instead this thing said going from -3 to 3?
It'd be negative.
No, no.
No, it's the same thing, yeah.
-3 to +3 if I'm trying to find that area.
Double, so,
It would be double.
yeah.
So this is a little hint. If you're ever going from -3 to 3 and you have a function that is it's an even function, like this is an even function, meaning it's symmetric with respect to the y-axis. If it's symmetric with respect to the y-axis, you just need to do from 0 to 3 and double it. Because going from 0 to something is nice, right? Because 0 being our bottom number, you don't have to plug it in because it's going to be 0, right? Okay, so that's a little hint, is if you're ever doing that, you just would have to double your result. Got it?
I agree, yeah.
Yeah, yeah. This guy, find the area under the curve of
Zero
cosine. Yep,
Zero
so you can
count,
see
I
that,
got it.
okay?
We're done.
Yeah,
Zero.
so like here, you're going from 0 to pi, and these two areas, this is a negative area,
Cancel.
they're going to cancel each other out. So let's see, he's going from 0 to pi over 2 of cosine of x dx, okay? What's the antiderivative of cosine?
1. No?
I think it's just sine. I don't think it's
I hate these.
negative
Pi
sign.
over 2.
So pi over 2 and 0. Okay, I'm going to draw a little bit of a unit circle here. 0 is here. That's at the point 1, comma 0, and pi over 2 is here. He is at the point 0, comma 1.
Alright, what are we?
Also,
Okay, we're doing
I don't know
sine.
what I got on my practical.
Cosine?
We're doing sine.
Cosine
Okay.
is sine. Yep.
Sine is the y coordinate, okay? So if I'm trying to find sine of pi over 2, sine of pi over 2 is the y coordinate,
Unit circle.
That's the one.
is 1, okay? And then sine of 0 is the y coordinate at 0, which is 0. So 1 minus 0, and he is, wait a second,
So like fourth period.
wait a
Go
second.
over it and then do it
That
with
shouldn't be right.
Something didn't happen.
Should be 0.
Seen her walk through it yet.
Yes.
It's
sine.
0 to pi, Comey, that's why. It's not 0 to pi over 2, it's 0 to pi. Oh, wait.
Find the area under the curve over the interval 0 to pi over 2.
So we're just finding the first
So,
chunk.
yeah, we're just looking at the first chunk.
We're just looking at the first chunk, yeah. So he has an area of 1. Okay, that's what this guy is. But because he's symmetric, this guy has an area of -1. So it says make a conjecture about going from 0 to pi, which would be 0, because you said that they were going to cancel out. You did your conjecture way before we even did part 8. Because you can see, because you know, right?
We didn't even answer the question, we just said
Beautiful,
no.
beautiful. What did you say? Oh, you didn't answer, yeah.
We didn't
We
really
did, we
answer any of
did.
the questions, we just said
We
no.
did. Find the area under, yeah, after you said no, right?
What are these?
Is there anything new that we've learned, or is this literally just what we've been doing?
This is a lot of what we've been doing.
Okay.
Yep.
Yeah, mine just-
Now, it's gonna get just a touch harder here, just because, like, we are not used to doing antiderivatives of x to the 1/2 power. We have.
That's true.
We've done a couple, okay?
Well, we don't need to do them.
So x to the 1/2 power, okay? Let's
Okay.
practice on doing,
Do
Um,
x to the,
yeah,
x
yeah.
to the 3 over 2.
Okay, if I add 1, here's how I cheat. If I add 1 to 1/2, it's 3 over 2.
It's, yes.
This is the reciprocal of that. 2/3 x to the 3/2, yeah? Going from 1 to 9. Okay. All right.
We're just gonna plug it.
2/3 times 9 to the 3 over 2 power. And then minus 2/3 times 1 to the 3 over 2 power. By the way, if you plug 1 in, it doesn't matter what it is. It's just going to be 1, right?
Yeah. 'cause
Okay,
it's right
so this is
there.
just minus 2/3. Okay, do you know what the 3/2 power means?
Squared.
Square root
Symmetric.
to the 3rd power.
Dang it.
Square root to the 3rd power. What's the square root of 9?
3.
3, and 3 to the 3rd power is
27.
27. So I have 2/3 of 27. What is
18.
2/3 of 27? 18.
Ooh.
18 minus 2/3. So the answer is like 17 and a third. 17 and a third. That was kind of a mess.
Way too big for that.
I actually hate thirds, just so you know.
You hate thirds. I hate thirds as well. You know why I hate thirds?
I hate them. Why?
Have I talked to you why I hate thirds?
Because
Okay.
1/3, 2/3, 3/3, 4/3, and 9/3, or like it's like point. It's 1. 3/3 should be point 9.
That's ninths.
Dang it. I knew it was
Well, yeah. I mean, like,
It's
okay, so 1/9, right?
No,
What she's talking about, 1/9 is 0.1 repeating. 2/9 is 0.2 repeating. 3/9, which is 1/3, is 0.3 repeating. What's 9/9?
1.
Not 0.9 repeating. Right?
Yeah, it doesn't make
Okay.
sense.
All right. Now, the reason why I hate thirds, I hate units of thirds, units of sixes, and units of nines because
They repeat and then they don't actually get
because you cannot, if you're solving stuff that involves thirds, ninths, and sixes, you can't convert it to a decimal. Because if you do, you will have rounded the decimal. And then you won't get the exact answer. Versus if you have halves or fourths or eighths or sixteenths or anything like that, or even a fifth, right? Those decimals terminate, right? 1/2 is 0.5. This is 0.25. This is 0.125. This is 0.2, right? All of those terminate, so you can use the exact decimal. If you convert it to decimal, you can type it into your calculator, you will get the exact answer. But if you type this into your calculator and convert it to a decimal, you will not get the exact answer because it's that fraction actually goes on forever, right? Or
What's
the
0.6 again?
0.16 repeating.
Why doesn't it?
With the
terminate?
6
Why is-
repeating.
why is it not
It's
a thing?
0.1666666666666.
And then your calculator ends last one is.
Right on the 7, yeah, but it's technically goes on forever, yeah. What?
Why? How? Why?
So why can't we say
Why don't they terminate? Why do some terminate and when some don't terminate?
I don't know.
It just seems. Does that not seem
seems
backwards?
What?
It seems weird that like some terminate and some don't terminate. Like, how can a number just like
It's because, so here's why. Here's why.
you know?
It has to do with the fact that like we count in like and everybody, it's not just the United States, it's everybody is in the base 10 number system, right? So like units of tens, like 11 is kind of like the equivalent of 1, but in the tens unit.
Yeah.
21 is the equivalent of 1 in the 20s unit, right? Those numbers, the tens is not divisible or doesn't reduce thirds. Does that make sense?
Okay.
So like because we count on the base 10 number system, it doesn't reduce
How
thirds.
else can you count?
Like you cannot divide 10 evenly
Yeah, into
by 3.
Yeah, I get that.
Now, I took a math class. God, what class was it? Logic, maybe? I'll have to go back there. They have you convert numbers to like base 2.
So there's only even numbers, or like how does that work?
So like,
Oh wait.
God, I have to look back again. We'll watch. Maybe I'll YouTube it and we'll see it here in a second. But like the number like 7 is equal to the number 1 in base 2
Yeah.
How?
because 7 numbers. You're just counting 1, 2, 1, 2, 1,
Because
2,
it's odd, so
1,
all
2.
odd numbers are
So all
ones.
the odd numbers will be ones. If you're counting in 3s, 7 would be 1. If you're counting in 4s, 7 would be 3. Does that make sense? Yeah.
Okay.
We'll talk.
That
I'll look it up as a YouTube video. Oh shoot! Oh
Did
shoot!
you do a trig review yesterday?
Like that just seems so easy.
Kind of.
I'm gonna make
Also,
Well,
Oh, yeah,
I'll look at a
7
YouTube
and
video.
3s is 1. What was the other one that you
What?
said?
What?
7 and 3s is 1. What's that?
7 and 4s is 3.
except for 1 7.
Yeah, what's 1?
1, 2, 3, 4. 1, 2, 3, 2. Yeah.
Mention all of them except 1/7. What's the deal with 1/7? Why is it like
0.1428571443.
Yeah.
Why are all of them like either? I mean, there's like 0.333, so that's like constant.
Let's go
I'm
through
not
these.
doing this right now.
So 7 doesn't repeat, but it doesn't terminate either.
What?
Why is
Seven
that
or-
the only one of 10 out of 10?
Probably should put my checkbook away. So no.
That doesn't terminate, or that doesn't repeat. You mean?
It doesn't repeat.
But like,
Well, I need to
Or
write a
doesn't
void
terminate.
check.
I would say it's because 7 is prime, but 3 is also
We're gonna
prime.
wait for my mommy to
I know. I know.
Just doing
There has to be some stupid reason for it. I don't know.
What did five?
I don't know.
Is two.
5 is prime also, and it does terminate. So I wanted to say it's because 7 is prime, but that's not true. Like, that's not the reason why. Like, that can't be the reason why. I don't know. I'll have to think about it.
Okay.
Okay, all right. These aren't even numbered. These aren't even numbers. This guy is x to the 1/2 power. But what do we do with these two exponents if we're trying to combine? Add them. So that's 2.5, which is
2/5. What?
5/2.
No, I was saying 2/5 for the.
What?
Oh, wait.
Oh, you're right. Oh, no. He's 5/2 first.
It'd be 1/3.
Yeah, I'm, yeah,
No,
okay.
wait. No. Pause.
2 plus a half is 2.5, which is 5/2, right? So this is, before we even start, we convert this to x to the 5/2 power, because then they're combined. Yeah?
7/2. Just 2 7.
Yeah, so if I add 1 to this, right, plus 1, 5/2 plus 1 is 7/2. So this is 7/2, but 2/7, x to the 7/2, right? Because 1 over that would flip it, right?
Is that right? Yeah.
And now I plug in 9 and I plug in 4. Okay,
Bar. 9, 4. Okay.
2/7 times 9 to the 7/2 power. We're going to find out what that is here in a second because it's going to come out nice. Minus 2/7 times
Wait, what was the
4.
answer for the
4
first
to the
one?
7/2.
17.
17 and a third.
That's how I think that's how we got started on thirds.
Okay, 7/2 power is the square root to the 7th. Yeah? The square root of 9 is 3, and 3 to the 7th power. 3 to the 7th power is huge. What's 3 to the 7th power? Somebody do it.
Good thing. 9.
Okay, I'm just
Times
gonna
9.
calculator.
3 to the 7th power is
Wait,
9
that's
times
one.
9 times 9 times 3.
Oh, boy, that's a big number.
2187.
2187. Okay, while you're on it, multiply that by 2 and divide by 7.
624.86. We'll go. We'll stop.
Okay, minus. This is the square root of 4, which is 2, and 2 to the 7th power is
Hold on.
huge.
We can do it.
128.
Times 2 divided by 7.
I've done that in my head.
36.57.
Okay, now, real quick, did you know, hold on.
What?
Okay, did you know that when you're subtracting numbers, right? Like this number minus this number is going to be a positive number, right? Okay, here's how I cheat. I
you
don't
just
retype
subtract it.
anything. I just take this number and I subtract this number and
And
think
make
in
it-
my mind it's going to be the positive of that, right? Like I don't retype anything. True?
Sure.
Do that when you're taking the ACT because it saves time. Like if you already have this in your calculator, just subtract that and turn it positive, right?
Really? That would make me more confused.
Right? No? Okay.
No,
All right, what do you get?
I don't know why, but that-
588.29.
Make it positive? Yeah.
588.29. What?
I'd like forget to make it the right thing, probably.
What's going on, Luke?
Okay.
Well, Eli's not doing his job.
Okay, what do we do with this one? Sine of x over 5. What do we do here? What do we do with sine of x over 5?
Do this for a second?
I don't want to do that.
Or just
You're on recording right now.
What? Do what?
close your eyes for a second so I can mouth the words.
Okay.
Yes.
I don't know what that was for.
I like.
Is he being naughty? A naughty kid?
Yes.
You're being a naughty kid? Okay. All right, what do we do with sine of x over 5?
Do at school.
I'm so lost.
No,
I don't know.
It's not even.
Luke, you're making it sound so much worse. You're making it horrible. Anyway.
All right, what do we do with sine of x over 5?
You left sign.
1/5 sine.
Ah, 1/5 out in front.
No.
We're just going to do a sine of x, 1/5 goes out front. Perfect.
Pretty nice.
What's the antiderivative of sine?
Let's go.
Negative cosine. So I'm going to do negative 1/5 cosine x line 0 to pi over 2.
I hate pi over 2.
Okay, explain. What
What?
did you just say?
What?
What did you just say?
What are you talking about?
I don't know.
The antiderivative of sine is negative cosine,
Yes.
right?
That part.
So I put 1/5 with him. Negative 1/5 cosine of
Okay.
whatever from 0 to pi over 2. That's it. Yeah, that's all.
I don't have room.
Okay, negative 1/5 times cosine of pi over 2
Wow, you are too good. 5.
minus negative 1/5 times cosine of 0. Okay, 0, I'm gonna do my little chart. If you guys have your unit circle, you can do your unit circle. Here's my unit circle. 0 is 1 comma 0, and cosine is the x coordinate. So cosine of 0 is 1.
So it'd be plus half. One
This
fifth.
guy is 0 comma 1. So this guy is 0. So 1/5 times 0 is 0. That's gone. Minus a negative 1/5 times 1, which is positive 1/5. And that's my
Oh, negative,
Answer.
negative, positive. Ah.
negative negative. Yep.
Wait, what happened? Negative 1/5. Okay, got you.
Got it?
Minus 1/5.
Got it?
Equals.
Got it,
I like when your brain goes out of word.
Your brain just short circuits a little bit.
Yeah, and then,
Yeah, that's
and then
what
you like
literally
hear the
just
word,
happened.
but we did your doors can't comprehend what the word means.
Supposed to be here today.
That's what happens
Then you
on
like-
So I'll bring them tomorrow. They're
No,
coming to
that's
my
what
house.
happens in normal conversations. So I say what, and then as you're halfway through re-explaining
Yeah,
it,
like
I
I
give you your
fully hear
answer.
someone and
Okay.
I go,
I felt
what?
really bad. Jalen's mom came up to me yesterday and she's like, "Hi, Luke," and I just sat there and stared at her and I was like, and I just watched her walk away and she's like, "Hi, Luke."
She's probably so pissed too. She's like, why did he say bye back to me? It's so rude.
Did she actually say that?
No, she didn't say anything about it.
I was like, wait, I'm supposed to say hi now, and I was like, oh, they're, I'm leaving now. I was like, that just happened.
Okay, secant
Okay,
squared.
what's the antiderivative of secant squared? Tangent?
Tangent, yeah.
Tangent x from 0 to pi over 3. I don't know what tangent of pi over 3 is.
Neither do I.
Power 3?
Can I type it in? Does that
I
work?
can do this. I can do this.
I-
that-
Minus tangent of 0. I know tangent of 0, 0. Is tangent of 0, 0?
Tangent of power 3.
Tangent of 0, 0. Tangent of pi over 3 is square root of 3 over 2. Square root of 3.
What are you doing?
I was gonna get that.
Square root of 3 minus 0.
Too slow.
Square root of 3.
I know, I'm really slow.
There you
That
go.
was like 10 minutes. Okay.
Square root
Hold
of
on.
Hold
You
on.
went
Three.
super
Well,
duper
well.
fast, and I got like 0% of that.
No, I think you got like a third of it.
No, not actually.
All right, do you think we can get these problems done, these 3 problems done before the bell rings?
You gotta slow down.
No, we
There's
can't.
only 10
ln
minutes.
of 3? No, we can't.
Oh my
No,
gosh.
this is so easy. This is so easy.
For
No, 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 no. What?
For Reese, probably.
Okay, no, no. Okay, hold on.
I hate you.
That's the right answer. No.
Not quite.
Oh, dang
Not
it.
quite.
Okay,
3/5.
step at a time.
'Kay.
I don't know.
All right, toss the 5 out front.
Cubed.
No.
No.
I'm trying to
Wait,
guess.
doesn't the E and the ln go away?
Yeah.
I'm gonna say
Right?
So 3 to the.
So
like
15.
negative 12 or something like that.
The
15.
antiderivative of e to the x is e to the x.
The antiderivative of e to the x is e to the x. So I've got 5 e to the x, plug in 0 ln 3.
Yeah, the E to the X and the
Okay.
ln.
So 5 e to the ln 3.
Oh, 5. 15 minus 5 is 10.
Ah!
Everly?
Did 10?
Okay.
I
Minus
don't even know.
5 e to the 0 power. Okay.
Isn't that just one?
1.
Hyman?
E and ln cancel. So this is 15 minus
Is it a 1?
minus
1.
1 times
Wait, how do we get
5.
Yeah, what?
Well, oh, because ln and e cancels.
ln and e cancel.
Hey, third
So
time
it's just
is
5
I
times
said
3.
10. Just took me a while.
Wait, can we scoot you back?
Reese, do you know a Jaime Everly?
A what?
Jaime.
How did we get 10?
The
Oh,
5.
5. There's a 5 there.
Jamie? Oh, it is Jamie.
I thought you were saying the 5 to the. I thought that was a 10. Like the 5.
Who said it?
Yeah, I was confused.
It was you, Maylee.
These are such nice numbers. These are such nice numbers.
It's Jaime. in
Not
Spanish.
Okay.
IGA, just like such a cute.
Oh.
That is cute.
What is it?
Maylee.
Maylee?
His name is Maylee.
Maylee?
Maylee.
Haley, that's cute. Crap, yeah.
Maylee.
That's a spelling nightmare.
No, I have time.
May.
You really don't.
All right. What's the antiderivative of 1 over x?
I couldn't
Fifth?
spell it.
I think it's either
It's
15th or
May.
15th.
It's May 1st.
That's not what they just posted on Instagram,
Well,
like yesterday.
they're
Okay.
wrong.
They're wrong for their deadline.
Go on Jalen's
Honestly, they have been wrong on their
Go on
deadlines all the time.
Jalen's.
Okay, what's the antiderivative of 1 over x?
E to the x.
No.
Ellen.
ln x.
I got one right.
ln x.
Negative e to
Yeah,
negative
here.
1.
Oh, this is confusing. ln of negative e
That doesn't seem like it's a normal thing.
Minus
So it's just -1.
ln of -1. Type that into your calculator.
1.
ln negative e.
So that's -1.
Oh, shoot.
Oh, it doesn't have a thing. You can't take ln of negative numbers.
What?
Why not?
You can't take ln of negative numbers. Right?
Why are you looking around?
Yeah, you're looking.
Oh. And also, I did it wrong. 1 should go here and e should go here. True? Take ln of -1.
Domain error.
You can't put negative numbers into an ln.
What did you just say?
Error.
Error.
So what
Okay,
does
here's
the
what's
error
happening.
down?
Check this out. ln, 1 over x.
What
I
does
was
it-
like thinking of putting the.
You can't have a negative on the bottom, can you?
Yeah, you can. You just can't have a 0.
Is that
What's wrong with ln of what? You can make it x to the -1 and then -1/2 x squared.
That's what I was first thinking.
What?
I don't know why.
I was not thinking.
Make it.
I was
Here.
thinking like put the.
Here.
Media literacy.
Yeah, well, hold on. If you make them x to the -1,
What is it, Joe?
what's what's -1/2 plus 1?
Half.
Or -1 plus 1?
0.
TED Talk. How
This is 1 over 0x to the 0.
So then it doesn't matter. It's
So undefined.
It doesn't have an antiderivative.
It doesn't have. No solution for that one, I don't
Here's
think.
English assignment.
You're joking.
No.
That one does not work.
It's fake name.
True. He does not have stuff. Interesting. Interesting.
Is the next one one of our thingies that's on our sheet?
I'm gonna read fake
Yeah, what's the antiderivative of 1 over the square root of 1 plus minus x squared? I think it's like inverse tangent. Check that. What is it?
I do.
Inverse tangent?
No, inverse sine.
Inverse sine.
Wrong.
Inverse sine. Oh,
Can't we do to 0?
inverse sine from -1/2 and +1/2.
We can go to 0 and double it.
It's 0.
Right?
It's
Can we?
0.
Didn't you say that with the negative?
Because
it
that
would be
makes-
But
double?
It'll be the same
inverse
thing.
sine is not symmetric to the y-axis.
Oh yeah, the zeros don't matter when it's
Oh
like
yeah,
this
because inverse
stuff.
sine is this way. My
Yeah.
bad.
Wait, is this way?
No, it's this way.
So we do inverse sine of 1/2 minus inverse sine of -1/2.
Which doesn't
Okay.
matter.
So you can type it in if you want to, or
Bloop.
look on your unit circle. Where is sine 1/2 at?
Oh no.
First quadrant. What value has
60 degrees.
60 degrees of sine? Are you sure?
This says 30.
There says 30. Is 30 sine 1/2 at 30?
What?
My
No.
inverse sine.
You're looking at cosine. Yeah, 30?
Inverse sine.
Okay, where is
I
inverse
guess I
sine
should
-1/2?
go
He should be in the
Fourth
Negative 30.
fourth quadrant.
Negative 30.
Negative 30 degrees.
So we go
So 60.
The answer is 60.
Are we in degrees or are we in
Radians.
radians?
No, we don't do radians here.
1/2 is probably in radians.
It probably is in radians, but it's fine. We'll leave it. We'll leave it. Okay? Yuck. What a gross thing.
No, my calculator
What a really
was
gross
in
thing.
radians today, and like I almost got my butt killed in physics. And then I said sine for some reason because I was looking at the completely wrong angle in our stupid triangle.
Yeah,
and it's
kept
like
saying
it's
sine.
tangent. I'm like I changed it the first time you said it's tangent. And then my calculator was still in radians.
All right, I'm going to shut the recording off.
And I forgot.
Goodbye.
I'm gonna